Okay. Let's see here. Okay. This is a guy I've been talking to too. He might want to join the stream. He seems to like all this stuff too, so I'm gonna send that link to him. Okay. Hello, Theo. How's it going? I'm wearing headphones, so I'm trying to gauge how loud I should be. Because it's also kind of late at night. Oh, you know something I should put in I should put in the link in the descriptions of my streams. I should put my playlist. Here we go. It looks like I can't actually add it after I started streaming. Well, okay, that's fine. Anyway. Let's see, where did I... Hello, Filthy Pit Dog, how's it going? Hey. Jan 2. We be running Jan 2. Yeah. Alright, so, let's see where I left off. I just moved this over from my laptop, which I'm running Fedora and Cinnamon on because it's my spare laptop, so it's kind of a bit of a workflow jolt to see it on my desktop. I'm doing pretty good. Yeah, I remember you were talking about how you changed MAGA to Maddox. Well, welcome to the stream. Oh, you know what I should change? I should, there we go. So, I'm doing something similar to my last architecture for instruction sizes, just because fixed instruction sizes is very unwieldy in binary size. So, like, if all of these instructions were fixed size, I would have 12 byte long instructions, and that's insane. So, what I'm doing is I have my last architecture, what I was doing. Alright, yeah, I can still call you MAGA. So, in my last architecture, what I was doing is each instruction had its own size, which made writing an emulator and assembler for it kind of annoying to do, because I had to basically write a giant match statement and say, like, hey, this instruction opcode, this instruction opcode, no. It was annoying to do. So what I'm doing in this architecture is every instruction family has a size. This means binaries might be slightly bigger than what they could be otherwise, but I think it's worth it because it's less to implement. So, like, for example, anything that starts with the 4 bits 0 just have 8 bytes, and then, like, let's see, yeah. Oh, and the opcode size is left out, hence why anything that begins with 0x9 is 0 bytes, because if I go down to 0x9, as you can see here, it's just these instructions which have no arguments. So I'm trying to remember what I wanted to do, though. Oh, yeah, so first I'm going to turn down the music in my headphones, just because it's kind of loud. And then what I'm going to do is I am going to add a register. And this register is going to be okay, so what I want to do is implement an MMU, but still gotta think how specifically I want to do that. You know what I'm actually going to do first? First, I'm going to add timing chips. So, like, you can tell a chip to do something after some time. And I think I'll have, let's see what I want to do. I'll have one timing chip, and you can configure it to, after a certain amount of CPU clock cycles, maybe, execute something. Actually, I'm thinking, if I base hardware, like, okay, so what I'm trying to get at is some way for the programmer to tell the CPU to wait a little bit and, like, defer something to the background. So then in a certain amount of time, the CPU will automatically execute some code. And this is how task switching in operating systems work. So what I want to do is figure out how I want to implement that, so then the programmer can say, hey, after 5 clock cycles, trigger this system interrupt. And I think the way I want to do that is actually, if I do it in clock cycles and I don't even need a separate chip, I could actually just have the CPU after every clock cycle check or increment a register. And when that register hits a certain amount, it will do the interrupt that I configured. Fixed length instructions usually make CPU design easier, so usually RISC stuff is fixed or semi-fixed length. Yes, that's what I'm doing. It's semi-fixed. It's not... So every instruction, the family of that instruction has its own size. So anything that begins with 0x0 is 8 bytes, but then like 0x9 is 0 bytes. Here, let me pull it up. Right here. So this is how I'm doing sizes. And this is also excluding the opcode, that's why 0x9 is 0 bytes. And the opcode is 1 byte, so that's how I'm doing things. So I'm going to add a special register, and I'm just going to call it VT for virtual memory table, something like that. Or MT for map table. VT. I'm going to call it MT. I think it's more clear. Let's see, what do I want the access permissions to be? I want the MMU to PT, page table? Oh, yeah, okay, PT. So R, only execution rings under 2 can read it, and W, only execution rings under 2 can write it. It will be 64 bytes in size because it will store a memory address. And the register ID will be 0B. Page table. I also plan on writing an emulator for it in C. Page table. Under context storage. This register holds the memory address for the beginning of the MMU page table. And I'll leave setting this register as the responsibility of the bootloader or BIOS or whatever. Also, Shazam, or however you pronounce it, can you confirm something for me? Is the BIOS on top of being the, the software that is guaranteed to be on your chip and at memory address 0, is the BIOS also, does it provide addresses that can be called to do things like draw pixels to the screen or handle input and output with peripherals? Is that what the BIOS does? Because I remember, I know the BIOS is an important part of computing, but I'm not quite sure what it is. Ah, okay. Yeah. Yeah, and then the CPU can either, yeah. Yeah, it's on a ROM. Rage against the compiler. I'm looking for the part where he talks about uh, I think this is it. He'll talk about oh, right. Okay, so it's an interrupt to the BIOS, right? Or maybe I'm misunderstanding. I don't know. But this is where I heard it. Like he was using the BIOS to print text, that kind of thing. So this register holds the memory address for the beginning of the MMU page table. Right, okay. Gotcha. Now, should page sizes be something that's configured with a register by either the kernel or bootloader, or should it be something that's just a static constant? How does that work? I couldn't find much about MMUs online, so I'm kind of struggling. Actually, just realized this is where doing mass internet searching with something like an AI might actually be useful, because an AI can aggregate everything from the internet and then just summarize it. Now, I would never use AI to program, but holy crap, it saved my butt with research. Let's see. Is the page size something you can... Is the MMU or memory page size configurable after the CPU starts up, or is it a constant that is defined in the ISA? The relationship between page size and CPU architecture is nuanced. While the fundamental page size options are defined in the instruction set architecture, they can indeed be configured after CPU startup. Let's break this down clearly. Modern CPU architectures define multiple supported page sizes as part of their ISA, but these sizes can be dynamically configured during system operation. For example, X8664 processors support multiple page sizes including 4 kilobytes, 2 megabytes, and 1 gigabyte. Okay, that's... hardware level. Oh, okay. So CPUs define what can be used, and then the programmer decides what to use, right? Okay. Okay. The blue section represents hardware level. I can't read graphs. I just simply don't understand them. Okay. I see. Okay. So is allowing the page size being used a complex feature, or do RISC CPUs often have it too? Oh, wait, hold on. Wait, I'm sorry, what? This can't be right, right? Hello, Fanta, how's it going? Is this right? That can't be right. I don't remember who you are. Do I? Can you remind me who you are? Did you have a username change? Fanta. Yeah, I don't remember. I must have known you by a different name. Yes, okay, I know who you are. How's it going? Yeah, you're the, yeah, I helped you with Hyperland and stuff. Yeah. Yeah, welcome to the stream. Yeah, I don't have problems with remembering people. I just, like, when people change their usernames and stuff, I don't know who they are initially. Okay, so page size used. Yeah. Yeah, I mean, I'm glad when people catch my lives, because it means I have people to talk with and stuff. So yeah, I'm glad you caught my live too. Actually, this project, so I have another CPU architecture that I made, but it kind of sucks. So I'm starting from scratch. I'm making another CPU architecture. Page size. No, PS is kind of a bad name. Any ideas what I should call the register for a page size? For the page size being used? Page scale, page selection, no. PZ. No. Page. The benefit of having my own CPU. Well, I want to make my own CPU architecture because why not? I want to program it on an FPGA, and also it might help me get into college. I also want to program my own operating system and my own programming language, and yeah, so really, yeah, I just want my own thing. I'm actually thinking of making it so I can actually daily drive this thing once it's ready. Yeah, valuable experience from my last architecture and people I can talk with about architectures, and yeah. So this architecture will be much better. I won't have weird ass instructions like copy memory block until null terminated data. Yeah, so get to it. Learn this stuff and work with me. And yeah, you can always like DM me on Discord and stuff and ask for help or work with me. I'm open. Holy shit, x86. Actually, I'm not surprised. X86 move instruction is apparently Turing complete. It's like, how do you fail that badly? That's worse than the US government spending like $30 million on a hammer. Let's see. Page. No, not. PC is such a terrible name for. Let's see. Yeah, very special hammer. Let's see. What should I call this? Fuck. I'll call it PS. Page size. I'll let any execution ring read it. C. Page size selection. Page size selection. This register holds the current selection ID. Holds the selection ID for the current MMU page size. Right? Is that... Oh, dang, dude. I'm sorry to hear about your Discord. Yeah, people on the internet be getting all weird. People at uni made a simple RISC architecture for educational purposes and called it mini RISC. There are a few docs about it on the internet. If you're interested, just search for the name. You made your own repo? What did you make it for? Mini RISC. Which one is it? Oh. Well, I hope you're learning the basics of Git, though. Git's very valuable to know. Is it this? Ah. Oh. Oh, wait, you guys can see the stream just fine, right? Yeah. BME mini risk. Is this? Ooh, light mode. Okay. Where is... I'll have to read all of this later, but I want to find MMU. No, that's not it. Is it case sensitive? Oh god, it's not case sensitive. Okay, good. Highlight all. No, don't match case. Does it have an MMU? Looks like it doesn't. Just realized this is my streaming workspace, so I can keep it in here. Work with APIs? What specifically? Okay, so what do you think? Should my defined page sizes go into the ISA or the hardware markdown file? I will Oh wait, I forgot to put music back on. The MMU is a component that maps virtual memory addresses to physical memory addresses, as well as also read/write protecting memory pages, and also let's see. I mean, if you have a Mac already coming on the way, go ahead, but honestly, I recommend something like a framework. Why can't I open Discord? Okay. Why isn't... Actually, I'll pin this. I don't need to open the tabs and clutter my browser. I can just pin it. Yeah, Vencord just doesn't work anymore. Weird. Yeah, I will take a look at this. Like, I'll take an in-depth look at this after the stream, because I can see how I can learn a lot from here. Oh, it does open. It just takes a while. Is it because I'm in a server? Huh. Yeah, that seems like one of those. I can close it. Oh my god. Okay, Discord. Okay, so let's see. The page table. The page table is a region in memory beginning at the address stored in the PT register and going up. Heh, I'm glad you liked my rice. Where are you from? You're new. Are you a YouTuber? You look like your profile picture kind of looks like a YouTuber's profile. Ah. Yeah, post some Linux content on here and I will subscribe. Ah, you know what? I'll subscribe. Yeah, you better put some Linux content on there. The page table. Its job is to map virtual memory addresses to physical memory addresses. The way it does this is by, let's see, how best should I word this? So, I'm gonna fix the colors here, make them not so. Ooh, okay, that's nice. So the way the MMU page table works is you have your memory address. Actually, I guess I could just write it as, I'll just do it like this. So okay, let's say you have a 16-bit memory address. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's say you have this 16-bit memory address. This is where page sizes become important, is because the amount of bit, like the bit ratio you choose for mapping depends on the page size. So, for example, if you allocated 8 of these bits to the inside address. So like, let's say our page sizes are 256 bytes. You would allocate these write bits to the address in the page, and then let's see what's a nice color. Ooh, I can't do lightness because that breaks the background. That's a nice color. Okay, so then I'll choose so this here will be the page number, essentially. And this here is the rest of the address, which is inside the page. And what the MMU is going to do is it's going to map this number to a different number. Fuck. Okay. So it's going to map this to a different number, and this is how virtual memory addresses get mapped to physical memory addresses. So this is what I have to figure out how I want to do. Oh, come on, GIMP. Don't be buggy on me. Not right now. Come on. Oh, fuck. This is why Fedora ships GIMP 3, GIMP using GTK3 in their official repositories, even though it's still kind of buggy, is because GIMP GTK2 on Wayland is horrible. The TLB. Oh, by the way, thanks for calling me a genius, but I do want to clarify that just because I know this doesn't make me a genius. I'm actually just regurgitating stuff that I learned online. So yeah. Also, these are nice colors. I'm gonna have to pick them with a color picker after the stream and then make a color scheme with these or something. Because I like these. You know what? I'm gonna copy this. Wait for Discord to come up. So, I'm not going to make a Rust programming tutorial. And actually, I have two main reasons why. One is, I think programming tutorials are overrated. If you want to program stuff, following a tutorial is actually not the main way you want to do it. It's actually kind of a horrible way. That's how you get stuck in tutorial hell. Following micro tutorials is what you want to do, which maybe I'll do something like that, who knows. And two is I've actually come to kind of resent Rust a little bit. No, don't even read the Rust book. It's the same issue with tutorials. You essentially just want to follow the 2080 rule. You want to learn what you're actually needing to use in the moment. I made a video about this on my channel if you want to check it out. It's how to learn any programming language quickly. And it's about just how you want to learn the absolute basics, and then, yeah. Spam. Oh, come on. Discord. Oh my god, I crashed it. Since when did Vencord become this unstable? Seriously. Bruh. Okay. You know what I'm gonna do? Oh, you gotta be kidding me. Fuck. Okay. I am using Desktop. That's literally what I'm using. I really want to save this image though, because it has nice colors. Frack. Oh. Discord, you are something else. Oh, it crashed again. What the fuck? Yeah, I don't like how woke Vesktop is. That's the thing I don't like about it. You can call me a bad person or whatever by saying that, but it's true. I don't like how woke it is. Yeah, I forked, I made Trump cord. I forked Vesktop on the election day, but I kind of just made that as a meme, just to mess with people. So I probably won't maintain it. I don't have the motivation to maintain a proprietary shitware, but I don't know if it's a Wayland issue. I think maybe it's just a Gentoo issue. I don't know. But this worked. I think maybe it's because I was pasting kind of a large image. It couldn't handle it or something. Just little Discord brain got confused. Oh. I'm gonna keep Discord open just so it's not. But yeah, so the MMU essentially just maps memory addresses to. Oh, what is going on here? What the MMU does is it maps memory addresses to different memory addresses. So by configuring the page size, you're essentially colon. What were you talking about? Do I have to use Google for this? God damn it. Colon window manager. Oh. Is this what you're talking about? '3D gaming window manager. Ooh. Oh, this is actually pretty cool. They had that for Windows XP. Okay, well... Okay, how do I... Sounds kind of messy to let the programmer modify the page size mid-runtime. So what should I do on the CPU side when the current page size is changed? How should I should I store the page size used to map an address to an address in the page table, like at the beginning or something? Yeah, that might be what I do. Oh, Hack Matrix Window Manager. Yeah, I know what that is. I could make it fixed. Yeah, that actually would probably be better. I'm gonna just make it fixed size. Page table, page size selection. Oh. Boom. Gone. Oh. I need the page table register. What am I doing? Just page size selection. There we go. Page size selection. Page table. Right. Do I mention pages anywhere else? Nope. Good. MMU. Is it called the page table register? Did I call it that? Yeah, PT. Okay. PTSD. The page size. The page size of this architecture's MMU is fixed at, what's a good page size? Let's just take a book out of Apple and do 16 kilobytes. Kilobytes. And I just want to be extra sure I'm not doing this conversion wrong, because this is official documentation. Kilobytes, yeah, 1,000 bytes, I thought. Just wanted to make sure I wasn't getting kibibytes confused. Kilobytes, 16,000 bytes. $16,000. Good morning, Harsh. How's it going? Yeah, dude, I'm a proud American. Like, a proud... Heck, I'm even Republican. That's as American as it can get, kind of. Like, as patriot as it gets. And... Yet I have to admit, dude, military time is so much better, and the metric system is so much better. My border on my notifications. Yeah, thanks. It's I'm using Sway and C as my notification daemon, so I have like all these different yeah. I use 12-hour time just because it's what I'm used to and it's the most convenient to reach for here in the US. I do, if I right-click my clock, I can see 12-hour time mapped to 24-hour time. And it's even a phantom notification too, so it doesn't get logged, which is nice. Hey, Crow, how's it going? Yeah, here, I can share it. Oh, shit. There we go. Now, Crow is someone that I met in an unlikely place. I met him when I was deciding to kill a few brain cells and play gorilla tag. Gorilla tag is a fun game, but holy crap. There are so many just children on there. Just spewing like the N-word and stuff. And I mean, I am a child, I'm 16, but like 8-year-olds. Nothing against 8-year-olds, but like 8-year-olds can get very rowdy. But it's fun. When I do VR, I like to do expert level Beat Sabers. Expert level Beat Saber. Let's see if I can find one of my older runs, because I know I sent it in one of the Discord servers. I think I sent it in here from... Maga, thank you so much for sharing this with me. It was stuck in my head for like 2 days or so. Yeah, this. And yes, I use an Oculus Quest like a freaking normie. But yeah. Play Beat Saber. Here. This is one of my older runs too, so I've gotten a lot better since this. Now I can do... There's one run that's really fun, and I can do it without missing any blocks. Like in this one, I was still panicking when I'm hit with a sequence of blocks. Yeah, so I'm missing a bunch here. Yeah, I can do better than this. I think this was also my first time playing this level too, so that also contributed to me missing some. And also these stringed together blocks are my biggest weakness, apart from constantly switching sides. Yeah, that was why I got it, is the price. Yeah, so this is an older run. I analyzed this run to death afterwards, and I got a lot better afterwards. The level I do now in expert mode that I don't miss a single block on is called World Wide Web. Let's see if I can find it. YouTube Beat Saber World Wide Web Expert Mode. Yeah, this. Let's see, is this it? It feels faster than this for some reason. No, this is it. Okay. Yeah, this level's a lot of fun. Because you just smack blocks side to side. I don't like how he's slicing them, though. It's like too parallel. Like, I'll go in circles and just have fun with it. Yeah, it is a lot of fun. Oh, I figured out why his footage seems so slow. It's because he's using like a footage stabilizer or something. I know this because I took footage of me snowboarding and skiing on my GoPro, and it was a new GoPro. I never used a GoPro really before, and I had the footage stabilizer on, and all the footage looked slow afterwards. Then again, my GoPro is also fisheyed. Yeah, I snowboard. I'm well, skiing is what I've done for years, but I started learning how to snowboard and I got decent at it. Going on blue runs on a snowboard. With skis, I started going on beginner black diamonds and stuff. But yeah, so that's one of my favorite Beat Saber levels. Yeah, I live in Texas, so I don't get to experience snow unless I go somewhere with snow. Well, actually, it's been starting to snow here in Texas, weirdly enough. The page table is a region of memory beginning at the address stored in the PT register and going up. Its job is to map virtual memory addresses to physical memory addresses. So, let's see. Um, Texas is very hot. Hold on, I gotta stretch my legs. Yeah, Texas is very hot. It will, in the summertime, it will consistently get up to like 120 degrees here. It's insane. And that's in Fahrenheit, not Celsius. That would be insane, 120 Celsius. Fahrenheit. No, Celsius to Fahrenheit. Oh, that's another thing. Fahrenheit kind of sucks. Celsius is what we should be using. 120. Holy shit. Yeah. Oh boy. 248 degrees Fahrenheit. Yeah, that would be fatal. Let's see, how do I want to do this? Yep, an American admitting that Fahrenheit sucks. 50 Celsius, that would be like 150, 130 Fahrenheit, something like that. Celsius to Fahrenheit. Yeah, okay, 122. Formula for converting Celsius to Fahrenheit. It's 9 divided by 5 times Celsius plus 32. I'm gonna... Actually, no. Bash doesn't have floating point numbers. So it's very annoying to do math in Bash with floating point numbers. Yeah, negative 40. Let's see. Celsius. Frick. My brain is so tired. Fahrenheit. Yep, negative 40. Okay, so, is Shazam still in here? Shazam? I don't know how... Sazm. Is Sazm still in here? Because I need their help. Actually, I could just ask AI again since it aggregates from the internet. Oh, what? Show me. No. I'm not gonna do that. Never. I am never paying for an AI product. Let's see. How does the page table work? Actually, how does an MMU work? Memory management unit. Yeah, Gabriel, aren't you a photographer or something? The MMU performs several essential tasks: address translation, memory protection, virtual memory management, allows programs large run, manages dynamic switching between RAM and disk. CPU, generate virtual memory address. Oh, I see. Check page table entry. But like... Divides memory into fixed size blocks called pages, typically 4 kilobytes. Maps these pages to physical memory frames. Maintains a page table for tracking these mappings. Translation look aside buffer, TLB. Isn't the TLB just like a cache for the MMU? Ah, alright, well I hope you find work soon. Well, when you're ready to find work. Let's see. Practical benefits. The MMU provides several important advantages. Process isolation. Each program runs in its own protected memory space. Prevents accidental and malicious interfaces between yeah, okay. Efficient resource utilization. Enables multiple programs to share physical memory safely. Virtual memory through paging to disk. Prevents memory conflicts between applications. System security. Enforces strict memory access controls. Protects sensitive areas of memory. Prevents unauthorized memory access attempts. But, like, how do we... Are page mappings stored? Page mappings are stored in hierarchical data structures called page tables, which are managed by the Memory Management Unit, MMU. Let me explain how this works in detail. Page tables are organized in multi-level hierarchy that maps virtual addresses to physical addresses. Here's how the structure looks. Oh. Yeah, okay. I'm going to try YouTube one more time to see if someone's actually made a useful tutorial.
This diagram illustrates the essence of a segmented memory management system. On the left are some of the programs that have been installed on the computer's hard drive. These are just files on a disk. In the middle is the computer's physical, the RAM. This contains any programs and data that are currently in use. On the right,
This light mode is horrible.
computer's hard drive. Each program that's currently might be a procedure or a function. A running instance of a program is called a process. Needless to say that the operating system itself has a number of processes in memory when the computer is working. Suppose the user starts launching applications. Sooner or later, the memory is going to fill. Notice how different processes occupy different amounts of memory. These portions of memory are known as segments. They're based simply on the sizes of the programs. For each process, the operating system knows its starting location and how big it is, so it knows where everything is.
Oh, dude, I've actually been asking Core Dumped over and over and over again to make videos on the MMU. Because I just can't find anything anywhere. You know, I actually needed a linked list recently when I was implementing hash maps in my C library. Oh man, I have to sign in to get rid of frick. Okay. Yes, I am a human. Remember me. Sign in. I just realized that someone could guess my password. Then again, I get security alerts. And I could also set up auth. I'll do that later. But yeah, anyway, I needed to use linked lists and stuff for my hash map implementation. Ooh, go to sleep.
When a request is made to launch some more software, perhaps a word processing application, something has to move out of memory to make room. If one of the processors belonging to the presentation software
My dad's going to bed.
is currently doing nothing, the operating system might decide to move it to disk, temporarily at least, so the word processing programs can begin. When another request is made, perhaps to launch a web browser this time, another idle process of at least equal size has to be moved out of memory to make way. In order for the spreadsheet process in the swap to start running again, something else of at least equal size has to be swapped out. Although there is enough free space to allow for this, the free space is fragmented. In a segmented management system, each process is atomic. It can't be split up. It's all or nothing. So the spreadsheet process is going to have to wait. The chances of the large presentation process getting back into memory are now particularly low, because a number of adjacent processes will have to become idle before this will happen. In summary, in a segmented management system, a swap between disk and main programs such as
What? This will probably be what I need.
Now let's walk through how to actually do this translation and what goes into it. Page table, virtual address, and our physical address. So our virtual address size is set by the ISA, and our physical address is set by the amount of RAM we have installed in the machine. So let's take a look at how this works. So the first thing we want to remember is we have this pages that are larger. So in this case we have 4 kilobyte page. We've got 12 bits for our page offset. That means with these lower 12 bits, the page offset, they're not translated. They just go straight through. So that means the remaining 20 bits of the virtual page number needs to be translated to 16 bits of the physical page number. How do we do this? Well, we use the page table. We take the virtual page number, we put it into the page table, look up that virtual page, and then we get out the physical page.
But like, how do you do that?
Page table will have an entry for every single virtual page. Each of those virtual pages wouldn't have the physical page number, or if it's not in memory, it's something that tells us it's on disk. So each one of these is a page table entry tells us for a particular virtual page.
So do you just have a shit ton of unused entries? Like, dude, is this just like an array? Oh my god, dude. Oh, that would be super space inefficient though. Oh boy.
Physical page is located at. And if you notice here we have different number of bits. We have 16 bits for each of these entries, we have 20 bits for each of these entries. And that's because we have more virtual pages than we have physical pages, because we have less physical memory than we have virtual memory space. Alright, so let's take a look at how this works. We take our virtual page number, we go find our entry, and that entry goes down to our physical page. The page offset, we don't change anything, it just goes through. So virtual page.
Oh, god damn you, MAGA. I have throw it back stuck in my head now. And it's like overwriting my ears. I'm not gonna click that. Oh God. I'm glad you like the stream.
Look closely, for what you see shall soon come to pass. For this event marks the crumbling of your world. The ancient serpent and the fallen are losing their grips on humanity, and in desperation have orchestrated one last stand. Your scriptures call this moment the Armageddon. The veil between the spiritual and physical is thinning, and the forces on Earth, motivated by power and greed, have inadvertently brought about what they fear the most. The dragon is coming. The sun will darken, the moon will turn to blood, the stars will fall from the sky, nations will rise against nations, and the world will be consumed by chaos. The trumpet blast will herald destruction, and a third of the earth will be burned. The seas will turn into blood, and all living things within them shall perish. The wicked will cry in agony as they see the lake of fire awaiting them. Men will long for death, but death will flee from them.
Whoa, Mr. Ophenim? This isn't working. Thanks for the help, though.
Are you sure about that decision?
Yeah. But we almost spooked him. Really? He's eating a sandwich. No, he's grabbing his...
Was that a fucking Moto Razor? I don't know. This video is very vibe conflicting. It's It's like it's a meme, and then this, and then a meme.
Dear God, please take care of my son. Please tell him I'm sorry. I couldn't do a whole lot better for him. God, I don't know if I believe anymore. What if it's part of your plan? Please give me my son back. Please give me my son back.
Thank you, MAGA. Actually, wait, no. Because you got it stuck in my head. I'm watching it because it was stuck in my head. Which, yeah, life hack. If something is stuck in your, like if a song is stuck in your head, listen to it, and then it probably won't be stuck in your head after that. Or, like, it shouldn't be stuck in your head after that. I don't know, it works for me. I don't know if it'll work for others.
Hi, Joe. This guy needs help with his car. I think he came from across another state. I don't know. He just was in the store as late. Brandon's late. I know. Must have making a call. I don't know. Look at Gabby on car. Looks real strange in the dark. Look, he's hearing them.
I guess I am built different, huh? It's like YouTube knows I'm a teenager. Why do I get thumbnails like this? This isn't even a channel I'm subscribed to. Like, YouTube just knows what I'm gonna look at. Like, just where I'm gonna move my eyes. Yeah, it's Google. Yes, I love Acerola. D-Arrow. I don't like using extensions that alter YouTube because they often alter it way too much. Like removing the entire recommendation section or removing my notifications bell, that kind of thing. It's like, but I like getting recommendations because then I know like what I want to watch and I end up learning cool stuff. Like, the reason I program in C now is because I saw Nick Barker, this guy, in my recommendation. I was like, oh wow, C's actually super cool. I want to program in C I want to program in C, and I loved it. Oh, that D-Arrow. I also don't like that because I want to see the true original video. Also, D-Arrow does a lot of like just spiteful stuff too. Like my Why I Left Nick's OS video got so many views that someone D-Arrowed it, and it now just says, I left Nick's OS because of FHS compatibility issues, which is dumb. And I'm like, yeah, I left it because of FHS compliancy issues, but it's not dumb. And also, I left it because I don't want to write a shell.nix because it's mandatory or whatever. Like, it becomes problematic when I want to compile source code from scratch. It's like, come on, bro. Oh my god, page tables really are just arrays. Actually, you know what? On second thought, that's not so bad. Because one, we're messing with actual physical memory, so it's like, okay, waste as much as you want on the CPU side. And two, usually if you're paging stuff, telling the MMU to map certain pages, you're mapping a lot of the pages that are next to each other. So, it's actually not that bad. Okay. Well, I'm gonna check your brain rot. I know it's a controversial opinion, but I freaking love Brian Lunduke. I am going to watch this after the stream. This is one of those things where if Mario and Peach are in a video, with a thumbnail like this, it usually gets kind of sus. Yeah, I am a hypocrite, aren't I? I mean, let me clarify. You can't post porn in this channel. This is just like where people can get political and stuff. Okay, fine, I'll watch it. I owe you that for being hypocritical. What the heck is this? Oh my god. Oh my. Oh. Okay. This is like, this is like, brain rot, but not for kids. Again! With the frickin' thumbnails! Come on. Legendary. Oh my god. It's one of my streaming inspirations. Yes. Swizzing, sodding, however you pronounce it. Actually, how does sodding like to write sodding in Cyrillic set Russian? Хороший учебный язык. Yeah, that's definitely not it. What is this spewing about? Sodding uses a Cyrillic script to spell his name as. Actually, that character kind of mystifies me a little bit. Sodding. 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 Okay, it's sodding. Sodding. Okay, now I know. It's sodding. Sodding. Kind of weird. Oh yeah, they're after me because I stabbed a guy. I'm kidding. I think they're just. I live in My dad's house is in kind of a reforming neighborhood. It's in a neighborhood that used to be very, very, very sketchy, but it's starting to get a lot richer, new houses and stuff. So he was been smart and he bought a house here, and he's gonna benefit once this neighborhood is super rich and like nice. And yeah, so you're probably hearing a lot of sirens because people get hurt here a lot or whatever. Actually, fun fact, I don't know if you guys know what Remco is, but it's like shitty car insurance that doesn't actually insure you. It's just because you need to legally have car insurance, at least here in Texas. And the Remco near us has, like, for a year and a half now or some long period of time, someone threw shit at the side of the building, like human feces, and it's just been there, and it's amazing. It's on the woman on the side of the building, on the Remco buildings. The Remco buildings are hideous, and they have this woman on the side who's like just smiling and crossing her arms, and the shit is right on her face. It's amazing. Save me, Mario. Let's see. If Mario was Indian, what would his name be? If Mario was Indian, what would his name be? Let's see what the internet has to say. If Mario is Indian, his name would likely be influenced by Indian naming conventions. Given that Mario is typically portrayed as an Italian plumber, his name in Indian context might be something like Mario Sharma or Mario Singh. Okay, I'll just say Sharma. Save me, Mario! Mario is not here, but his brother Sharma is here. How would you like me to save you? Oh, by the way, your computer has a virus. And don't worry, for those of you saying my impression is offensive, I've had Indian people enjoy my impression, so I'm confident using it. Hello, your computer has virus. The tangent. Yeah, this was the thing about my streams. They go on so many side tangents. I am not too confident in the quality of this tutorial though, because this guy is not Indian. If any Indians are watching, love you guys.
Well, we use 16 because 2 to 16 is 64K. So we're going to use the lowest 16 bits here, so it's 15 0. And then now the virtual page number just removes the 16 bits. Now we're going to have the same thing down here, the page offset, where the physical address is now 260 bits. And we're using fewer bits for the physical page number. So if we go ahead and do a translation for this, we're going to have to do fewer bits. So as we saw here, here we have 60 bits for the virtual page number. So our page table is now going to be indexed.
So, you know what I'm gonna do, actually? So, here's the thing. Here's the thing. Actually, hold on, let me look this up. Does x86-64 use 64-bit addresses? Oh. That is interesting. So here's the thing about, he's throwing it back, sir. So 32 to the 2 to the power of 32 is this long number divided by 1 billion. So a 32-bit address length, so a 32-bit address can address a 4 gigabyte address space. Obviously, older computers got around this with tactics like paging and whatnot, but they could technically, a 32-bit address can only address up to 4 gigabytes of memory. Now, let me do 2 to the 64. Yeah, okay. A 64-bit address can address up to 18,446,744,174 addresses. Gigabytes. That's insane. Now how about 2 to the 48? That's not so bad, is it? Yeah. Okay, so 48 is a bit more manageable. Pay your taxes and do your homework. Then again, if you're committing tax evasion, I don't blame you, considering we were paying for like sex change operations in Guatemala and crap like that. So hopefully Trump's gonna fix all of that, but yeah. The whole thing is sending money to foreign countries for seemingly useless things to American people is, yeah, has to stop. Okay, dude. That video was actually... Oh, we should probably watch this. Yeah, okay, this guy's gonna be a lot of help. Ah. Yeah, my dad's a business owner, so he's lucky in that regard. Technically, he's a corporation owner. Oh, okay. So this video will solve the... Mm-hmm. Oh. Mm. Hello, Elm, how's it going? Quote of the day? Yep. Oh, that's the quote of the day. Thought you were talking about he's throwing it back, sir. That's a nice quote. Be quick in your actions and silent in your doing, motto of a thief. Oh. Oh. I see how that works. Why does this girl keep ending up in my recommendations? Then again, I probably just boosted her in the algorithm by hovering over her. Ah, okay. You're making a macOS inspired hyperlane rice? Yeah, good luck with that. I tried to make a hyperlane rice for the Pine phone, but the Pine phone just sucks. So... yeah, a Linux phone that doesn't suck. That'd be awesome. I'm thinking, should I bump this page size up a bit? No. Let's see. How many... What is 2 to the power of 16? Oh, I should have known that. So, let's see here. A memory address in my ISA is 64 bits. let's say I want to allocate the first. I'm gonna write this so I can visually see. So I'll record a macro. 1, 2, 3, 4, 5, 6, 7, 8. Five, 6, 7, 8. Okay, that's 8 bytes. Right. Let me remove the space. Yeah, that's 8 bytes. So let's say I want to split it. Think splitting like this is good for the first page table, like that for the second page table. Should I have a third page table like that? No, that'd be too slow in memory. Here's what I'm gonna do. I'm gonna split the mappings for the 2 page tables. But that would give the page tables a lot of... Well, actually, let's see here. Oh, my pages are 16 kilobytes, okay. So, first off, what is... Oh, okay. Here's a really nutty idea. What if I have the first page table has 16 bits, and then the second level page table has 24 bits. Oh boy. You know what? 8, 16, 24, 32, 40, 48. Actually, what if I just took a book out of x86 and just did 48-bit memory addresses? Nah. Let's keep this simple. Hi, headset. How's it going? You're married to foldable phones? Ah, I mean, good for you. I don't know if I could ever bring myself to use a foldable, to be honest. Okay, let's see. How do I want to split these? Okay, first off, what is 2 to the power of 24? Excuse me. That's 16 million. No. 2 to the power of 17. Too many bits. How about 2 to the power of 10? Or 2 to the power of 13? 2 to the power of 12. Okay, so I think I'm gonna make page sizes 4 KB bytes. KB bytes to bytes. Let me make sure I have the conversion right though. 496, yeah. So 496 page sizes will be 4 kibibytes. The page size of this architecture's MMU is fixed at 4 kibibytes or 4 KIB. Dang it. Calculator. What's, dang it. It's 496, right? I need to make sure because this is official documentation. $496. What is 496? Do I need to get the square root of 496? 64. That doesn't seem what I need. 2 to the power of 12. Yeah, okay, so it's 2 to the power of 12. So, hey Ogla, what resources did you use to learn this? The only things I really know are the fetch, decode, execute, and opcodes, and yeah, that is it. I don't know about virtual memory or pages. So I am using this channel, which I found out about in this live stream. And then another really useful channel that I've used to learn a lot is youtube.com/coredumped with 2 P's. So yeah, those 2 channels. And then if you want some more like technical, then you can do Ben Eater. Oh. So 12 bytes, or 12 bits. Yeah, Ben is amazing for a 12. So this will be the addressing of a page. And then that makes it so how many bits is this? 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52. 52 divided by 2 is 26. Yeah, 26. So 26. Where do I divide this? 1, 2, 3, 4, 8, 12, 16, 20, 21, 22, 23, 24, 25, 26. 1, 2, 2. So 8, 16, 24, 26. 8, 16, 26. Okay, so this will be the schema for splitting. 26, 26, 12. So let's see here. The page table is a region of memory. I should call these I should call these map tables. I'm gonna call these map tables. The page table is actually no. Yeah. No, you know what? The page tables. I'll call this page tables. Page tables are a structure in memory that maps virtual memory addresses either to more page tables or directly to physical memory addresses. I'm thinking, how should I structure this? In this architecture, virtual memory addresses are 64-bit. The first 26 bits, the first 26 most significant, the first 26 most significant bits are used for mapping, to another page table, which then uses the next 26 bits to map to a physical memory address. The last 12 bits are left alone. Those are used for actually indexing locally in the page itself. Hello, Elm. Welcome back. What are Ben's? Ben Eater. He's a YouTuber. these characters. How did I format that? Yeah, like that. Okay. Level 1 page table translation. Page table index. I should actually have, I should probably have 3 page table levels, because 26, what is 2 to the power of, 2 to the power of 26? That is, that is 60, hold on. That's megabytes, right? Megabytes to bytes. Yeah, holy crap. So that'd be 67 megabytes for a single page table. How about something more reasonable? 26, 52 divided by 3. Hold on, guys, I gotta pee. Haha, it rhymes. Alright guys, I'm back. By the way, water break. I was super dehydrated. So, y'all need to get water. Now, I changed into my nighttime clothes, so I'm in my super awesome epic hacker hoodie, TM, which is awesome. Think the Primogen's hoodie, just mine is thicker and cooler. Actually, never mind. Nothing will ever beat his hoodie. His hoodie's amazing. And I think he has a zipper too, whereas mine is a slide-on. Though my hoodie's pretty amazing too. Alright. Ow! Shit. I just hit my knee on my desktop. Ow. It has sharp corners too. Okay. Ow. Swell. Yikes. I hope it didn't damage anything. Oh. Oh. Also, the one thing I liked about living in Texas is no longer a thing. It's the fact that my skin didn't get super dry super quickly here. Now it's getting dry, and I have to constantly apply lotion. Which is kind of ironic considering my ancestry is from the mountains of, like, Slavic countries. So, yeah. My mom quite literally grew up in the Soviet Union. Okay, level 1 page table. Let's see, how do I want to split this? 52 divided by 4, 13. Plus 2 to the power of 14, of 2 to the power of 13 again. That's not so bad. But it's still a lot of translate. You know what? Yeah, here's what we're gonna do. We're gonna go to 48-bit. So that means I have to redo this. Level 2 page table index. Local page index. America's West be like? Vim, nice. Bruh, I don't know. Also, this is not Vim if you're referring to this. This is Helix. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. How many bits is this? Oh, I should put on music again. Yeah, why are we listening to this music, actually? When, So we have 4, 8, 12, 16, 20 bits now. Didn't hear what? Oh. There, now you can probably hear it better. There we go. Maybe I'll make it 30. 30. Yeah. Let's see how loud it gets. Yeah, that's, I'll make it 35. There we go. I think that's good, right? So, maybe I'll make it a little bit quieter. Yeah, down to 50 or 48. I feel like 45's good, right? Give me feedback if the music level is not so good. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 20 plus 20 is 40. So actually, this is wrong. I need to take off 10 more bits. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's see here. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 plus 13 is 26. Plus 12 is 26. 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. What did I do wrong? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. What? Four, 8, 12, 16, 18. Okay, so 18 plus 18 plus 12 is 48. Okay, so 48. And what is 2 to the power of 2 to the power of 18. 18. So this would still be kind of unwieldy at would it though? Actually, hold on. Let me put this number in as no, actually. This is not bad. When compared to, let's say, a gigabyte. Yeah, this is not bad. How about a megabyte? So, I guess it's kind of bad. It's fine. It's fine. Actually, calculator. 48 minus 12 is 36 divided by 3. 12. Actually, I could do... Holy crap, okay. So 48 divided by 4 is 12. I could do 3 page tables and have 12 bits for each. I think that's what I'm going to do. Is 14 gigs of space normal for an EOS install? 14 gigs of space normal. Dude, I don't know, actually. I mean, it does sound like a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My brother just came in the room. 12, 18. Yeah, okay. There we go. So now bit layout. Okay, let's see. Actually, I could have kept that like that. Then yank and paste. There we go. Level 3 page table index. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. Okay. How many bytes are in 48 bits? 6 bytes. This means I have to update other parts of my ISA. Actually, nah, it'd be 48 bits. Yeah, that's a lot of gigabytes. So 48-bit addresses are fine. Memory addresses are 48-bit in size, but the machine doesn't need all that much memory. When the CPU tries to access memory that doesn't exist, a hardware interrupt is raised. The same hardware interrupt for failing to access memory due to physical shortage is also triggered when an address in an instruction is let's see. So, immediate 8. Okay. 6, 8 bytes. 10 bytes. So 10 bytes needed for that. 3, does 3 need 10 bytes? Yes, 3 needs 10 bytes. 4, does 4 need 12 bytes? So everything in 4 can now be 10 bytes. And then how about 5? No. 6. Six can now be 6 bytes. Yeah. How about 7? 7 needs to be 8 bytes. Okay. 8. 8 needs to be 8 bytes. And the rest seem to be good. argument size. Description. Type. Reg. Size 2 bytes. A CPU register. A CPU register ID plus split info. I wonder what things would have been like if you weren't like 3 years old when Cicada. What's Cicada 3301? Also, I was born in 2008, so I don't know. Like, was I 3 years old? Mem. 6 bytes. A memory address. In 8 bytes. Immediate data. An integer, really. Cicada. Yeah, DM it to me. I love that kind of thing. I like things I can just listen to in the background when I program. Those are my favorite kinds of videos. Cicada 3 Yep. Oh yeah. Yeah, you're gonna send me the video, so I don't need to read up on that there. memreg gym for, I want to verify something, 10. Memory address is 6. Reg, yeah, 10. Okay. memory. When a memory address is passed to the CPU for the CPU to when an instruction instructions that use registers to extract memory addresses truncate the most significant bits off. Since memory addresses are smaller than registers. Whenever the CPU tries to access a memory location, the address is always translated through the MMU first. When the MMU is activated, the memory addresses that the CPU tries to access are first passed to the MMU to translate from virtual memory addresses to physical memory addresses. The MMU is not on by default. In this architecture, virtual memory addresses are 48 bits, 6 bytes big. A page table is a structure in memory, is a chunk of memory. Hold on, how should I do this? A page table is a structure in memory that maps hold on, I'm going to test something. Calculator. 2 to the power of 12 times 2. Okay, 2 to the power of 24. Yeah, okay. A page table is a structure in memory that maps indexes to other values. These are specifically used for translating parts of a virtual address to parts of a physical address. The way they work is the part of the physical address is added to the starting index of the page table in memory, and then the entry at that address is read, and depending on the level of the page table, that entry either translates to the starting address of another deeper page table, or it translates to a physical memory address. A page table is a structure in memory that maps indexes to other values. These are specifically used for translating parts of a virtual memory, virtual memory address These are specifically used for translating parts of a virtual memory address to parts of a physical address. The way they work is the part of the physical address is added to the way they work is the part of the virtual memory address is added to the starting index, starting address is added to the address for the page table start in memory. The way they work is the part of the virtual memory address is added to the address for the page table start in memory, and then the entry at that address is read, and depending on the level of the page table, that entry either translates to the starting address of another deeper page table, or it translates to a physical memory address. Entries. Page table entries. Page table entry size and layout. Page table entries are dang it. Page table entries are page table entries are frick. Oca64, why not Oca 128? Because why do we need 128-bit processors? 32-bit was like the last, like that was the last point that we actually needed to upgrade. 64 bits is insane for computing, actually. So it's just not worth it to go up to 128 bits. So here's the thing. The trade-off is that yes, you can store bigger integers and registers and stuff, but your instructions will be bigger, meaning binaries will be bigger. And like it just doesn't make sense, because let me put this into perspective. You can already, on a 32-bit machine, without any memory mapping or anything like that, a 32-bit machine can address a 32-bit machine can have, without any funny mapping or anything, 4.2 gigabytes of RAM. Now, a 64-bit machine a 64-bit machine can have 18,446,744,074 gigabytes of RAM. So, like, you don't need to go bigger than 64-bit. In fact, the Nintendo 64 is probably a mistake to go 64-bit. Because also 64-bit arithmetic is slower. Yeah, it'd take forever to download that much free RAM. Two to the power of 12. It's 496 bytes. Now plus 6 times 12. No, yeah, 6 times, no, times, no, bytes plus 44096 times 6. Yeah, it's pretty terrible. What are you even gonna do with 128 bits? Like, to programs nowadays, like x86 64 programs, they oftentimes still use 32-bit registers and 32-bit memory addresses. Like, it we haven't even fully utilized 64 bits in today's day and age. I have 128 gigs of RAM in this machine, and that is nowhere close how much RAM I could have with a 64-bit computer. Also, this music's freaking me out. Okay. Right. 1590 behind me. Water broke on it. Your water broke on it? Aw. Hope the baby's okay. Yeah, I can't bring myself to get NVIDIA stuff. I use AMD hardware. Ooh. Did I add this? Yes, I did. I need to delete this playlist. It's just full of random stuff. Stuff I don't even listen to, really. What do you mean I'm brave? Yeah. Actually, it's kind of funny that I use, I like AMD hardware because it's, supported by Linux really well. AMD is good. I've had amazing performance with this, so I'm not complaining. I have a full red setup, AMD CPU, AMD GPU. Have you actually used an AMD GPU? They're actually quite good. Yeah, you should seriously try AMD hardware. Page table entry size. Oh, you know what I could do? Instead of... Okay, so the page entry size, page table entry size will be the page table entry, a page table entry size, the size of a page table in this architecture is... Did I do all these songs, actually? No, I did not. The size of a page table in this architecture is... Page table... Oh. The size of a page table entry in this architecture is 24 bits. I'm not doing, I'm not doing like crazy 4K gaming, and I'm not doing AI stuff. So having an AMD GPU for me is quite good. I also don't want to experience the shitty driver support for NVIDIA on Linux. It's not that shit, but it's just chaotic compared to the plug-and-play aspect of AMD GPUs on Linux. Like, let me reiterate, the NVIDIA driver on Linux is actually not that shitty. It's just external. The built-in driver for NVIDIA GPUs is simply meant to get you up and running. Novu, it's terrible. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Excuse me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 3 bytes. Welcome back, Maga. I'm still working on my MMU. Oh shit. Okay, you guys are still here. Good. I'm glad. Alright, let's see. Okay, so. Why am I storing the key? That's so stupid. I'm not gonna add numbers on top of the zeros, I'd just make it weird. More confusing to read. Get the key. Get the key. The key is the result of multiplying x by the size of a page table entry in bytes. There we go. Offset. Get the entry memory address by adding the memory, by adding the key to, get the entry memory address by adding the key to the corresponding register's value interpreted as a memory address. Get the entry memory address by adding the key to the corresponding register's value and interpreted as a memory address. In this architecture, there are 3 page table levels. Each page table level has a dedicated register for holding the start address for that page table. You paid for all the numbers? Technically, you just paid for a bunch of rocks. Well, fun fact, the IEEE standard for floating point numbers, it literally supports infinity and not a number, which is JavaScript levels of shitty weirdness. No. I'm making my own CPU architecture for a few different reasons. 1, learning experience. 2, to flex on people. 3, to get into college. 4, because I want to try and make my own computer that I can actually daily drive. Yeah, dude, if I can port Linux to this thing, that'd be awesome. Get the entry memory address by adding the key to the corresponding register's value interpreted as a memory address. The memory address is now pointing to the memory address is now pointing to the memory address is pointing to the 16-bit value stored in RAM in big endian format. Gentoo, about the same, I would say. The thing with Gentoo, though, is you can compile everything from scratch, and you can add CPU native flags to your build options. So you can actually optimize everything that you compile. So in the worst case scenario, Gentoo has the same performance as all the other distros. In the best case scenario, Gentoo outshines other distros in performance. It really just depends what you have in your make.conf file, and if you decide to use bin packages or not. same as other distros? Well, if you, again, it's the same. If like I compile Java from source and I have CPU native optimization flags to compile, like, so then when I'm compiling Java, it's optimizing the crap out of it, then I'm gonna have a faster Minecraft than any other distro. Also, as for War Thunder, I don't actually play War Thunder, so... Lol. What inspired the name Oca64? Simple. Oglo's CPU architecture, 64. I think it's a really nice name too. It has nice symmetry. Why? Why leg? To compete with arm? And you could clone arm. You could have, so arm has thumb mode. You could just make toe mode. Let's see, what do I need to write? How to access the value of a page table entry. Bit layout. That explains why I'm confused. This should not be down here. This should be up here. This part is given to the L1 page table to figure out where Something doesn't seem right. Head. This part is given to the L1 page table to figure out where the... Hold on, I need to watch that guy's videos again. Alright, see ya, MAGA. Have fun. Yes, please bring more Brian Rot. We need more Brian Rot. No comment. I'm pretty terrible about my sleep schedule, but I also don't encourage staying up late. Dude, go to bed. Go to bed now. Okay, so yes, penis. Let's see here. I need to do math. Ugh. First of all, I gotta remove these two registers. Touche, 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 touche. $24,000 bytes times 100. Honestly, this is not bad. Okay. So I am promoting the size of a page table entry to 48 bits, 6 bytes. HDL. Can you remind me what that is again? I don't really talk in acronyms. Oh, I'm probably actually going to, you know, I think I'm just gonna make my own solution, that, I'm just gonna make my own kind of Logisim clone, but it supports 64-bit address buses and stuff. So that's what I'm gonna do for like the visual, just me sort of conceptualizing hardware. I also want to program this on an FPGA, and I also want to build an emulator for it in C. As for when I want to put it into a language that describes hardware, maybe I'll use VHDL or whatever. 1, 2, 3, 4. 48 bits, okay. Part of me really wants to make sure this is 48 bits. And I want to do it satisfyingly. Yeah, it's 48 bits. I'm trying to figure out how I can I'm on a brainwave. I'm just trying to figure it out. Okay, this is good. So, Oh, thank you. Hey, hey, Damon Powell. You seem new. Welcome to the stream. I try to remember everyone who I come across on the internet. Feels more personal. Good way to make friends. Okay, so M is... Yep. You start... I'm gonna start listening to my focus list. Yeah, okay. There we go. Alright, sure. Okay. It's not that hard to remember, everybody. Does chat rewind with the stream? Okay. Yes, so... Damon, are you here, like, are you at the current moment of the stream? Okay, so yes. Oca64 is the name of the architecture that I'm making. And I'm currently working on implementing the MMU specification. Though it has been challenging because the MMU is a field of CPU architecture that I'm just now learning about, like how to implement and stuff. And it's very hard because there's not much on the internet about it that's actually good. So yeah, that's really all the context that you'll benefit from. The other context is just me like randomly looking at memes or working on some mundane parts of the CPU architecture, like figuring out how big memory addresses should be and stuff. So you're fine. Are page table indexes the indexes of memory? I don't know much about computer engineering. Okay, so it's both complex and straightforward at the same time. So a page table index is a page table is like an array. Actually, it is an array that stores, in my architecture, 48-bit values in big endian form. big endian just meaning the most significant byte of the 48 bit number is stored first in memory. And what the index is literally the index into the page table. The page table is quite literally a lookup table. You just multiply, like for example, if you want to get the item, the value, the 48-bit value at index 2, you just do 2 times 6. 6 is 48 bits in bytes. So 2 times 6 plus the starting address of the page table. And that will be the address for the value you want. I hope that explanation makes sense. The local page index is the last 12 bits tacked onto the least significant side of the first 36 bits. The local page index is the last 12 bits tacked onto the least significant side of the first 36 bits gotten from the L3 page table, and this final 48-bit number is the physical memory address that is the full physical memory address that the virtual memory address translates to. Is the first two page tables like the virtual address, and the third one the physical one? So, so there are multiple page tables, because if I had one page table that took in the first 36 bytes of the virtual, the first 36 bits of the virtual memory address to translate into a physical memory address, that would is this music too loud? No, but it's getting there. So the if I had one page table that simply mapped the first 36 bytes, 36 bits of a virtual memory address to the physical memory address 36 bits, that page table would have to have it'd have to have about 68 gigabytes allocated to it of just static RAM. Because remember, at the CPU level, there's no malloc or free or anything like that. It's all just static RAM. You hog what you need. So 68 gigabytes of memory would be used simply for the page table. And this is insane. So what we have instead is a level 1 page table that points to a level 2 page table, which points to a level 3 page table, which then points to the 36 bits needed, which is a lot more manageable. Hello, Shiv Panchal. How's it going? So let's see. Yeah, I mean, I guess I'm not going to guide you through this entire thing, but you're welcome to stay and watch, and if you have any very specific questions, I can answer them. Yeah, just ask me questions and I'll answer them. The best way to learn, probably, if you can't do, then watch. That's what I would say. So watch me program this thing and you'll learn a lot. Technically, I'm not programming right now, I'm just designing stuff. Let's see. And if you don't understand what you're looking at yet, that's fine. The learning process is like that. It's just stick around and then eventually it'll make sense to you. And again, I'll answer any questions. Let's see. Page size. Yeah, okay, virtual memory address. Level 1, page table index, level, okay, page tables, page table entries, page table entry size, page table entry layout, value as well, yep, okay, how to access the value of a page table entry, okay, translating a virtual memory address into a physical memory address. Address translation. Address translation is the act of translating a virtual memory address into a physical memory address. Yeah, so if you don't have any specific questions, then I recommend just sticking around and watching and see what you understand so far. That's when the specific questions will come to you, is if you are trying to understand something, but there's just something that doesn't make sense. You can ask me, like, for example, hey, what is little endian? What is big endian? You keep saying big endian, little endian. What actually is that? That kind of thing. I know learning can be a frustrating experience, but it's a good experience. It's very valuable. Address translation is the act of translating a virtual memory address into a physical memory address. From L3 page table by passing in the next 12 bits of the virtual memory address. This value contains the first 36 bits of the full physical memory address. The 12 least significant bits get ignored. Yes, it does make it slower, but it's also necessary, because if I did bigger page tables, like if I made the key for a page table way bigger, that would mean a lot more memory would have to be allocated to the page table, and it would just get unruly very quickly. So having this almost linked list type of structure is pretty much necessary. And I'm doing three depths, 3 levels of page tables, and it shouldn't be too slow, but it will ultimately be slightly slower. And this is why I'll have instructions that the kernel or bootloader can use to whenever they need to go fast, they can turn off the MMU. Now, this actually is not much of a problem because it's already assumed that accessing RAM is slow. So having this extra translation gives us security. It gives us RAM security, so programs can have their own address space. But it also simultaneously makes RAM, you can protect pages of RAM too, memory pages, so that certain pages are read-only kind of thing. And so it's worth it to have that little bit of slowdown for all these extra pros. The cons, the pros far outweigh the cons. I'm gonna actually go to bed now after drinking like 5 pints of water, because that's another thing I've just kind of neglected today. Okay, good, Gabriel, you need sleep. It's probably already light where you are. Yes, so the MMU is very important in modern computing, and yeah, it, like, for example, if you've gotten a segmentation fault from trying to dereference a null pointer or something in C, what that is the MMU stopping you from accessing address 0 on the computer. Because what's happening is the MMU is seeing, okay, you're accessing memory that was not mapped to your process. You're accessing memory that was not mapped to your process. And the thing with that is that it can be dangerous. If programs are able to overwrite memory arbitrarily, it can be dangerous. So what the MMU does is it sees you're accessing memory that you're not allowed to access, so it throws a CPU hardware interrupt, and the operating system handles that interrupt. And what it does to handle that interrupt is it throws a segmentation fault and basically terminates the program. So that's what a segmentation fault is. It's just accessing memory you're not allowed to access. Yeah, CPUs are awesome. It's definitely a rabbit hole worth getting into. I also want to add diagrams to this specification. Excuse me. GIMP or Krita? Nah, let's do Krita this time. I'll make it 4,000 by, no, I'll make it 1366 by 768. I don't know. I chose those numbers because that's the resolution of my little HP Stream 11 laptop. So I just decided it'd be a good resolution. Ooh, you know, I'm gonna get a little spicy. I'm gonna make the background of this picture clear. And just for the sake of actually making this thing, I'm gonna paint it, not that, but black. So first I'm gonna start by creating an outline. A 10, can I type 10? Yikes. Can I type 10? There we go. 10. So I'm going to create a 10. That's too much. 5. So this will be a page table. And I actually want to choose a different color. I want to make orange. The Krita color picker really sucks. Let's see. I'm gonna use. Kind of want to use. This orange. And then for the fill tool, I'm going to choose a slightly lighter orange. Can I? Ugh. The Krita color picker sucks. Can I do this at least? No, I can't. What the fuck, bro? I mean, I can. It just sucks. Okay. I'm gonna do that again. I'm gonna add 25. That's not what I wanted to do, bro. I'm gonna add 15. Oh my god. 15. 15. There we go. Now I'm gonna hit OK, and then I'm gonna... what? Oh, hey Whale, what's up? How's it going? Oh, are you kidding me? I don't want, the Krita fill tool kind of sucks. Never use a fill tool anyway. Oh, well. You scare me, bro. Now I need to make boxes that are white. Let me get the selection. 12 pixels. 15 pixels, so I need what? Oh my god. I know. Oh. That's interesting. I want to, I'm gonna, frick. There we go. So copy that. New layer, paste. And where's the transform tool? Now I want to delete this layer and merge this one in. I'm just making a diagram for my CPU architecture stuff. Does Krita have... No, it does not. Oh wait, Krita has a dedicated line tool, right? That guy who keeps messaging me is very entertaining because he lives in the Netherlands and he claims that, like, he knows more about the political happenings of where I live, even though I live, like, in the heart of it. It's quite entertaining to talk to him. It's like, no, you live in the Netherlands. You don't know what it's like to live here. You've never been here. It's very entertaining. Like, people get all mad at me for being a Trump supporter, and then and then they, like, come and visit the US where I am down in the South, and they're like, and then they leave with a different perspective. They're like, instead of being all mad at me, they're respectful of it, which is what I want. I don't like political stigmatism. I wish we could all just get along. Why is this so annoying to draw? Okay, interesting. It's 6 pixels. 6. And then draw that. Okay. Yeah, alright. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, the Krita pixel size slider is so annoying. Honestly, Krita is just kind of annoying, but it actually works on Wayland, whereas GIMP is just buggy as hell on Wayland. It's so bad that the Fedora repositories, like the official Fedora package repositories, package the release candidate version of GIMP that's super buggy, but it uses GTK3, so it actually works fine on Wayland. Uh-oh. Bum bum. Amukas. Amugus. Where's the transform tool? Here it is. This is therapeutic. Oh, nice. Nextcloud. Okay, first I need to see how many pixels are here. 37. 3. So there should be 40 pixel. There should be 20 pixels on each side. I don't know how that happened. Oh. I see how it happened. I actually like Krita. It's more annoying initially to learn, but it's actually quite nice. So now there are 20 pixels, 20 pixels, good. And now I'm just going to duplicate this. Oh, come on, Krita. There we go. There we go. And then copy. Yeah, LibreWolf sucks because it disables a lot of core web stuff out of the box for the sake of privacy, but it's just too paranoid with privacy to the point where stuff just breaks. Actually, I'm gonna... Okay, brightness has to stay the same. Saturation can change though. But I want to keep it the same. Let's see, how about... purple. Yeah. Well, if you try using anything with WASM or WebGPU or anything like that, WebGL in LibreWolf, it just won't work. Actually, what am I doing? 1, 2, 3, 4, 5, 6, 7, 8. Two, 3, 4, 5, 6. There we go. So I'm going to say like that, Make this arrow go all the way here. All right. Have fun with Florp. Want to copy this layer. If I hold down shift, oh, no, that's not what I wanted to do at all. Gonna draw an arrow like that. And then I want the output of this to go here. There are a lot of creepy noises coming from outside my house right now. went to 5. Yeah. Okay. And then L3 will be here. How do I edit stuff again? Do I have to go up here? Yeah. L2. So that's L2. L3. L1, L2, and L3. Yep. You probably could, but I don't know. I think maybe it might be browser specific, like on the website end of things, so I probably wouldn't. Ooh, my wrist needed to be popped. Now it's time to get rid of this background. Boom. That's the diagram. Which means it's probably a smart idea to make that blue text dark. Or no, okay, that's good. Yeah, you know what? I'll keep this background, but I'll make it a slightly more pleasant dark. There we go. Now make it like 2 1 2 1 2 1. Yeah, that's better. Nice. Save. Why are you saving shit in my home directory? Come on, bro. I could probably turn it off. Settings, configure Krita, miscellaneous. I don't know if there's a way for me to make it stop. How to turn off Krita auto saving. Okay, so no more auto-saving. I appreciate, though, that auto-saving is a feature. Is there a way for me to embed files in a markdown file, like images or videos, but reference it by path local to the markdown file instead of a URL? Oh, that makes sense. There we go. Now I can make sure this actually works by markdown previewing. Wrong file. Is this another terminal? Oh. Yeah, okay. I don't need you open. There we go. Nice. Oh, you know I'm wasting 12 bits when getting the final physical address? Well, I don't actually have a way yet to see if an address is protected. So you know what I'm going to do? I'm actually going to use those 12 bits to dictate whether or not addresses are protected. Actually, how do I want to do that? How do I want to do that? Good. I'm glad everything works. Let's see here. I'm gonna have 2 registers. And these 2 registers will dictate the usable memory region for a process. Actually, how do I want to do this? Excuse me. Okay, bound start, bound end. The two registers BS and BE store the writable memory address chunk bounds for userland programs. This range includes the memory address stored in BS, but excludes the memory address stored in BE. If the CPU execution ring is 2, and the CPU and the virtual memory address being translated is not within this range, the I need to make a new interrupt. MMU not. OB Virtu. Ubvertu. 8. The Ubvertu. The the ubver2 hardware interrupt is triggered. When the MMU encounters a virtual memory address out of bounds while the CPU execution ring while in userland mode. It's 2 o'clock. I don't care. I'm still going. But thanks for looking out for me, bro. Yeah, I just kind of go to bed whenever I feel tired. Oh, what did I just do? I just go to bed whenever I feel tired, really. Not really. Would you rather get work done or just lay in bed and do nothing? Well, good morning, bruh. ubver2? Yep, ubver2. Need to add a new CPU flag. MMU. When set to 1, the MMU is active. The MMU translates memory addresses. When set to 0, memory addresses are interpreted as physical. ISA, gotta add some more instructions. I'm gonna add some 0 size instructions. MMU on, MMU on, MMU on. MMU off. There we go. So now I have 2 more instructions. And I gotta add them to this whole thing. MMU on, MMU off. Set the MMU flag to 1, effectively turning on MMU address translation. There we go. So now that is MMU. Okay, so that's how the MMU gets turned on and turned off. Now I'm going to leave actually reading and writing page tables up to the actual program itself. Let's see, what else do I have to do? So, okay, I have everything here. Okay. So I believe that is the MMU implemented, which is sweet. So we got MMU. Yeah. What are some other hardware interrupts that might need to be triggered? I don't know. Okay, now I need to add the cycle chip. And let me just look at that beautiful, yeah, cool, we got an image. I'm going to move MMU to MMU and page tables. Oh, dude. That sucks. Also, quit redacting the messages. Bruh. I'm gonna rename this to virtual memory. Right, I want to add a timing chip. Yes, Helix. My favorite text editor. I do have NeoVim around for when I want to do very specific things, but Helix is my go-to. Micro is more like nano though, right? It's not modal. I just need a command line text editor. Yeah, everybody does. Yeah, I mean, that's fair. Oh my god, dude. Careful not to exclude one of those greater than signs. 'Cause yeah. Huh. The amount of cycles. The amount of cycles. Now, real sigmas use a hex editor. The amount of cycles that the timing chip, that the timed chip should wait for before, the amount of cycles that the timed chip should wait before triggering the, I'm gonna create this interrupt first. Before This interrupt will be called timed int. Timed int. When the timed chip waits for the specified amount of clock cycles in the WA register. Hardware interrupt. The timer's hardware implementation is up to the implementer is up to the creator is up to the builder of the CPU. The only requirement is that once triggered, the timer will wait for n clock cycles to go by where n is the value in register, and then the timer's hardware implementation is up to the builder of the CPU. The only requirement is that once triggered, the timer will wait for n clock cycles to go by, where n is the value in the WA register. And then it will trigger the timed int hardware interrupt. The timer will not start until the timer instruction is executed. The timer will not start until the timer instruction is executed. The timer will not start until the timer instruction is executed. Once the timer waits and triggers the hardware interrupt, it will wait to be triggered again by the timer instruction. The timer will not start until the timer instruction is executed. Once the timer waits and triggers the hardware interrupt, it will wait to be triggered again by the timer interrupt. Wait to be triggered again by the timer instruction. Zero XC 0. Zero XC 0. Timer 0xC0. Trigger the timer to start. Trigger the timer to start. Timer. This flag is written to by the timer. When the flag is 1, the timer is triggered and waiting. When the flag is 1, the timer is triggered and waiting. When 0, the timer is off. You know, I think there might be a lot of money made by Spotify if they made some sort of way of joining a Spotify session with a streamer. Oh, yeah, that's true. Oh, not what I meant to do. There we go. Dormant. Is that how you spell dormant? How to spell dormant. I'm gonna spell it incorrect on purpose. Dormant. 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 Like, you could get around copyright completely by just not including music and having each person join individually. True. Yeah. Yeah, that is true. You make a good sales point. Yeah, I format the tables manually. It's not so bad, though, to be honest. I just realized I shouldn't have a timer flag. So that is the MMU and the timer implemented into my ISA. I'm going to stop soon here tonight, but I think before this I'm going to write a document explaining what should be read first, like in what order, because my specification files kind of reference each other. Actually, no, because that would be very hard to manage in the future. What else should I write? I could spend some time beautifying these. me see how all these work. Look. Okay. I have so many old playlists in here. It's insane. Mm. Okay, so there's that. How am I liking Florp? It's working very well. The rendering issues might be because Florp is based on Firefox as opposed to some Chromium base. In NVim, I say Markdown, Preview, Indian terminology. Huh. Weird. What site is it? Hello, Pizaroo. How's it going? Oh, that's a problem. Oh, wait, never mind. Okay, that works. Yeah, thanks for stopping by. I hope to see you in the next stream. Okay, so that I think is all I want to do today. I'm gonna keep this open. Okay. Another thing I want to do is, instead of making an assembler for this CPU architecture like I did for my last one, I'm going to make a general purpose assembler and then make a file that imports all my custom instructions into this assembler. It's like load RLL0 RLM0, for example, 0x 0xFF00BA HLT. Okay. I also want to add a little thing to here. Okay, well, see you guys. That was a good stream. I'm going to go now. So, see ya. Bye-bye. 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 Three, two, one.